Sorry, guys, had a little hiccup there. So we're in part 2 of scientific method, day 1. So taking our previous example of our hypothesis, we're going to try to use increase and decrease in the hypothesis. So for example, we could rename that hypothesis as, if I increase the amount of food I give my cat, then she will increase her weight. In identifying variables in step 4, this is where you test your hypothesis. There are two main types of variables. The independent variable is the variable that is changed by the scientist. It's often called the variable that I control. And the dependent variable is the variable that might change because of what the scientist changes. It is the variable that's being measured. And remember that your hypothesis can tell you what your variables are. That's what we just talked about with the if-then statement. The if part of the statement is the independent variable, and the then part of the statement is the dependent variable. So drinking Mountain Dew, the amount of sleep. Use this hypothesis to identify the variables. If I leave all the lights on all day, then my electric bill will be expensive. Pause if you need to. But the independent variable in this statement would be how long you leave the lights on. And the dependent variable would be the amount of the electric bill. If I brush my cat more, then there will be less fur on my furniture. Independent variable is how often you brush the cat, and the dependent variable would be how much fur is on the furniture. Okay, now we have an experiment to read. Elizabeth wanted to test if temperature affects how fast ice cream melts. She left ice cream out at room temperature in the fridge and in an oven that was turned on low heat. She then measured how long it took the ice cream to melt. So what do you think is the independent variable, and what do you think is the dependent variable? Pause if you need to. And the independent variable should be, in this experiment, is how fast the ice cream melts. And the independent variable is the temperature, and the dependent variable is how long it takes to melt. For controls and constants, this is something that often gets confused, but a constant is something that the scientists make sure is the same throughout the experiment. So in an experiment where we test the effect of water on plant growth, a constant would be something like the amount of water. What are some other constants you could think of? A lot of times they're the tools that you use in the lab, and you can even use the example of the tester themselves. So if we always use the same beaker to measure, or graduated cylinder to measure the amount of water, you can include that as your constant. That's just another example. The control is the part of the experiment that the scientist doesn't change or add the variable to. It's often called the standard to which all other results are compared. So keep your eye on both definitions. And in an experiment where we measure the effect of water on a variable, the control would be the group that isn't placed in the water. Sometimes a control can also be like a placebo, if you've heard that word before. And in the conclusion, the results of the experiment, the conclusion is the results of the experiment, and this is where we find out if our hypothesis was right or wrong. And that, my friends, is your notes for today, and I will see you all in class. Okay, thank you. Bye.